The blueprint of creation. Complete dimensions in engineering drawings. Engineering drawings are the language of manufacturing. They convey the precise instructions needed to transform an engineer's vision into a tangible product. At the heart of these drawings lie dimensions, the numerical values that define every facet of a part's geometry. These dimensions dictate the size, shape, and position of features, ensuring that components are manufactured with the accuracy and consistency required for proper assembly and function. Complete dimensions, therefore, are not merely numbers on paper. They are the very foundation upon which successful manufacturing is built. Imagine, just for a moment, a skyscraper built from a blueprint missing critical measurements. The consequences would be disastrous, leading to structural instability and potential collapse. Similarly, incomplete dimensions in engineering drawings can cripple the manufacturing process, leading to a cascade of costly and time-consuming problems. Just as a building relies on the precision of its blueprint, so too does manufacturing depend on the completeness and accuracy of engineering drawings. Gaps in the blueprint. Defining and illustrating incomplete dimensions. Incomplete dimensions, as the term suggests, refer to the absence or ambiguity of critical measurements within an engineering drawing. These omissions leave room for interpretation, jeopardizing the accuracy and reliability of the manufacturing process. Imagine a drawing of a simple rectangular plate with only its length specified. Without the width dimension, the manufacturer is left to guess the designer's intent, potentially leading to a part that is either too wide or too narrow for its intended application. This seemingly minor omission can have significant downstream consequences. The plate might not fit properly with mating components, leading to assembly issues. Or the altered dimensions might affect the part's structural integrity, leading to premature failure. This example, though simple, underscores the criticality of complete dimensions in ensuring seamless and successful manufacturing. The domino effect. How incomplete dimensions cascade into manufacturing failures. Manufacturing is a complex ecosystem where each stage is intricately linked to the one before it. This interdependency makes the manufacturing process highly susceptible to the butterfly effect, where even seemingly small disruptions can snowball into major problems. Incomplete dimensions are one such disruption. When dimensions are missing or unclear, manufacturers are forced to operate on assumptions, introducing a dangerous element of guesswork into a process that demands precision. This guesswork can manifest in several ways. Manufacturers might contact the design team for clarification, causing delays and potentially halting production. In other cases, they might proceed based on their own interpretations, leading to parts that deviate from the intended design. These deviations can result in a range of issues, from minor assembly difficulties to major functional failures. In essence, incomplete dimensions inject uncertainty and risk into every stage of the manufacturing process. A catalogue of catastrophes, exploring the consequences of incomplete dimensions. The ramifications of incomplete dimensions extend far beyond the immediate frustration of a delayed production line. They can manifest in a variety of ways, each carrying its own set of costs and consequences. One of the most immediate and obvious problems is assembly issues. Parts manufactured with incomplete dimensions might not fit together as intended, leading to delays, rework, or even scrapping of components. This not only increases production costs, but can also impact delivery schedules, potentially damaging customer relationships. Beyond assembly, incomplete dimensions can compromise the functionality of the final product. A component manufactured with incorrect dimensions might not operate as efficiently, or, in a worst-case scenario, could lead to catastrophic failure. Imagine a critical component in an aircraft engine manufactured with a slightly smaller dimension than intended. This seemingly minor deviation could have disastrous consequences, jeopardizing the safety and reliability of the entire aircraft. The potential for such failures underscores the critical importance of complete and accurate dimensions in engineering drawings.